Good afternoon, everyone, and I hope you all are doing well. And thanks for joining in the session. I hope you all find it insightful. So, today's presentation is about, what we say, one of the most talked technology nowadays, that is blockchains. And it would be, really interesting to know that blockchains was first proposed in early 90s to find a computationally practical solution for timestamping the digital documents. So, they could not be backdated or tempered. But the actual use or the popularization of blockchains started in 2009 with the introduction of cryptocurrency. So now let's get deep into what is actually a blockchain. So, blockchain is a growing list of blocks that are linked together with some references. And every block records information in a way that it makes it difficult or impossible to change or hack the system. You see in the figure, we have three blocks, block 1, 2, and 3. They are linked together, and that forms a blockchain. And further, new blocks can also be added to the chain. So, what actually a single block consists of? The one block has three parts. It has one is the data, the second one is the hash, and the third one is the hash of previous block. Now, the hash is what? It is a unique reference of every block. So every block is assigned with unique references known as hash. And the second part of the block is the hash of previous block, where that means whenever we need a link to the previous block, we have the value of hash of the previous block to the block so that the link can be formed. And the third part of the block is the data, which can be anything. For example, like a transaction. So a complete block is formed with the data, the hash, and the hash of the previous block. And whenever there are multiple blocks linked together forms a blockchain. Now we have different types of blockchains. Uh, Particularly, we have public blockchains, the private blockchains, the hybrid blockchains, and the consortium blockchains. In the public blockchains, it is a permissionless blockchain. That means it can be accessed by everyone and accessible to everyone. That means it is an independent blockchain, and with the being independent, it is also transparent. But that would be the lack of security and performance. So the use case of this particular type of blockchain can be cryptocurrency or document validation. The another type of blockchain is the private blockchain, which is a permissioned blockchain. That means that it is controlled by, or there is an access control, and it belongs to one entity or one organization, and that means that it provides a good performance. And the use case of the private blockchains can be the supply chains or the asset ownerships. The another type of blockchain we have is the hybrid blockchain. And hybrid blockchains are the blockchains that are controlled by the single organization, but with a level of oversight performed by the public blockchains. And these for performing some certain validations. And hybrid blockchains can be used for medical records or the real estate purposes. And the last type of blockchain is the consortium blockchain, which is a permissioned blockchain, just similar to the private blockchain, but it is governed by the group of organization instead of the one entity. And that means it is more decentralized than the private one and being more secured. Therefore, these types of consortium blockchains can be used in banking, in the research purposes, or in the supply chains. So that's about the different types of blockchains we have. Now, we might wonder that how blockchains are so secured and how it is very difficult to access or tamper the blockchains. So because that is because of the following concepts or the following mechanisms. And the first one is the hashing. The hashing concept helps us to make blockchains secure. So you see in the figure, we have three blocks with their unique references known as hashes and the previous hashes. So what exactly happens is that we assign a unique hashes to every block, and the previous hash is the hash of the previous block. But we see in the figure, the first block, the previous hash is 0. That means the first block does not have any link to the previous blocks. So here, the first block always have the hash 0. And that is the concept of hashing. And but what happens is that nowadays computers are so fast, and they can actually recalculate all the hash values very fastly, so that these blocks can be tempered. So due to which the blockchains had a new concept or the new mechanism known as proof of work. So, what proof of work does is that it slows down the creation of new blocks. So, whenever a new block is created, it will take much more time to create that new block. That is why what happens is that it makes it harder to tamper with the blocks, because if we ever try to tamper even a single block, we will need to recalculate all the proof of works for all the following blocks. So these are the two above techniques that made blockchain secured. That is the proof of work and hashing. But there is one more way that blockchain secured themselves, and that is by being distributed. So this blockchain actually uses a peer-to-peer network, and anyone is allowed to join the network. So all the network participants have the full copy of blockchain. Instead of using the central entity, we have the whole complete network. When someone, like any one of us, tries to create a new block, that block is sent to everyone in the network. Like we see in the figure, we have the fourth block, which is sent to everyone in the network, and it gets checked by each node for the tempering. If every node creates its consensus and give the validity of the new block, and therefore it is added to the chain after the validity. So that is about the distributed system that secured the blockchain even further. Now, while I was going through and reading about the blockchain's technology, I came across this IBM Food Trust, which is a blockchain solution for the food supply chain. And IBM Food Trust is they built it on blockchain, which benefits all network participants with a safer, smarter, and more sustainable food ecosystem. Now, the food ecosystem, we might think it might be small, but the whole food ecosystem is very large, starting from the growers, those are the farmers, and then the farmers give their produce to the processors or the food production companies. Then these food production companies ship their products via their shippers to the retailers. There we have the regulators who keeps a check and regulates the quality, and finally the finished product received by the consumer. So the IBM Food Trust solution, what it does is it connects participants, all the networking participants, through a permissioned, immutable, and shared record of food provenance, transaction data, processing details, and much more. Now, IBM Food Trust has overall more than 100 companies, including Nestle and Walmart, which are their networking participant and working together for the digitization of transactions and data to provide a more efficient way of working across the supply chain. So that was the one of the use case of the blockchain that is particularly used nowadays. And there are more further there is much more what we can actually do with the blockchains. So the first one is we have cryptocurrency. Yeah, most of us actually are using it or invested in crypto nowadays. And the second one is odometers in our cars. So whenever we go to buy a second-hand car, so what they actually do, the sellers, what they actually do is they tamper the odometers to get the more value of the resale of their cars. So with the help of blockchains, what we can actually stop the tampering of the odometers in our cars. Then further, we can work the use case of the blockchains are going on to the digital voting. Then we have banking and healthcare systems, and really, really much more. Now, going on to the point that when to use blockchains. So whenever we have a lot of data manipulation, lot of dynamic data, and then we have multiple participants or writers in our systems, and the participants can't actually be trusted, and we have a shared and common database, there we can use our blockchains. But we should not use blockchains when we have really, really much confidential data and we have a large amount of just the static data. And there are some problems where we can find the simpler alternative available we have, then we should not use the blockchains. So I would like to conclude my presentation with a quote from Brock Pierce, who is the American entrepreneur, and he quoted that the blockchain is going to change everything more than the internet actually has done. So, yeah, of course, the internet has revolutionized everything around us, and it is said that blockchain is going to change much more. It has the tremendous potential to change everything, starting from the digital currencies, authenticity, supply chains, food industries, healthcare systems, and whatnot. So, thank you, everyone.